I am 3 students. We are going to be talking about describing functions from a graph. Primarily what we're going to be focused on is the degree of a function and also its concavity. And we already talked about that in the last lesson with in behavior. So keep those things in mind as we go through this. Now, what you're going to be getting some practice on with this is going to be this delta math assignment. So it says it gives us a polynomial function, and we want to determine a few features about it. Okay, now we could ask a lot more questions. Like if it had numbers, we could ask what is the y-intercept, what are the x-intercepts. We don't have numbers here, so we're really just focused on some of the in-behavior ideas and the concept of the degree of the function. Now we know the degree of the function is the highest power. Okay, so look at the first thing it wants to know. Is it odd or even? Well, we don't have an equation, so we can't look at that highest power to say. But if you remember from in behavior, the idea of odd and even, that's going to help us out here. But we're going to write down a few notes. So first off, let's talk about degree. Again, it's a very important part of describing polynomials. We're going to write down some little bullet points. So the degree, if it's even, function is going to be going, or the graph, the lines on the extremes, or the furthest ends of the graph are going to be going in the same direction. And that's what we'd call, that's our in behavior. Okay, then it also could be odd, and what we're looking for from the graph is opposite directions on the in behavior. Right here is exactly what we need. We're going to write down a lot more bullet points about degree because there's a lot of important details with that. But the in behavior of this is going to negative infinity on both sides. It's going down. They're going the same direction. So since they're going the same direction, we're going to say that it's even. Okay, and if it was both going up, if they were both going up, we would say it's also even. Okay, let's write down a few more notes. So make sure you have this. Let's write down just a few more notes about degree. Okay, so a cool fact is that the degree is equal to the number of zeros. That's always going to be true. Now there's something special that we're going to talk about as well, but let's look at this. So it goes through once, twice, 3 times. Well, that's interesting because we said it had to be even, right? But there's only 3 zeros that we're seeing. So look right here at these parts right here. This is just touching the graph, and this one's sort of going up and through it. Okay, so what these are indicators of are what's called multiplicities. Okay, so we have to look out for those. So we have the idea of multiplicity. Okay, so this idea is it's where it's touching the graph, touches graph. So here's some examples. I want you to draw these. If you have a polynomial and it just touches the graph like so, okay, this one goes through, this would count as 1. This would count as 2. So this would be a degree of 3. Okay, but we count that twice. Here's another example, one that we're seeing here. So if I go up, sort of sideways and up, and then down, okay, this little 0 right here, we count 3 times. okay? And this would count once, so this would be a degree of 4 total. And you can notice how this is odd and this is even right here. So that's what we're seeing on our chart here. So there's 3 right here, so 1, 2, 3, 4, 5, 6. So this is a 6-degree polynomial that we're looking at, okay? Something else interesting, doesn't really apply to this one due to the graph, but it's something that we can notice later on. We'll say times the number of extrema. So we've already defined extrema, the relative max and minimums, is 1 less than the degree. Yeah, that's not necessarily the case here. We have 1, 2, 3 relative max and minimums. We know that this is a 6-degree polynomial, but there'll be other examples where we'll see that. So now we need to figure out this lead coefficient business. And again, this all ties back to that end behavior. And it's the idea of concavity. We have our rules. The right side is going down. So if the right side ends going down, and the lead coefficient is negative. Okay. And then continuing, same sentence kind of. If left side, or excuse me, if the right side, same side, so we're looking at that right side, is going up, lead coefficient positive. Okay, so let's go ahead and use this rule. Make sure you wrote that down. Let's use this rule on this example here. You can notice on the right side it's going down. So based on our rule, if the right side ends going down, we say negative. So now you're just sort of counting the how many zeros there are. Well, we already said 1, 2, 3 real zeros. Even though these are multiplicities, we're only going to count them one time. So we're going to type in a 3 here. Okay. Then the relative maximum value, so maximum, how many are there? We're putting counts. There's 1, 2, so we're going to put 2 in there. We're going to submit that. We got it correct. So here's the zeros and the maximums, and we got the correct response down here. Let's try one more. So here we go. Look how they're going opposite directions. So that's something that we wrote up here. We're talking about the degree. It's even if they go the same direction, odd if they go opposite directions. So on here they're going opposite directions, so it's odd. Leading coefficient, we're looking on to the right. You'll see that it's going up. So that is going to be positive. Then we just count real zeros. 1, 2. There's 3 times that it touches that x-axis. Those are the zeros. Relative maximum values. 1, 2. And that's how you want to answer these questions. So that's just, there's more than one way to describe these functions, but that's the purpose of this skill. It's very abstract. There's no numbers. You're just sort of going through the definitions that we've been learning in here, okay? So let's go ahead. I'm going to an example with you guys. I want y'all to practice this with me right now, and I'll give you feedback immediately. So first off, Start, is this even or odd? So I'll pause it and you answer. Okay, if you put even, you're correct because it's going the same direction. Same direction. All right, the leading coefficient of this function, even though we can't see the equation, is it positive or negative? You should have put positive on this one because looking at the right side, look how it goes up. It's going positive. All right. With a response, how many zeros are there? So you should have said 1, 2, 3, 4 for that. How many relative minimums are there? On that one, you should have said 2. Be it. Let's do one more. Okay, so on this one, odd or even, you should have said odd because they're going opposite directions. The leading coefficient, positive, negative. So on this one, it is negative. It's going down on the right side. How many real zeros are there? So I'll give you a second. You should have said 1, 2, 3 of them. What about relative maximum values? You should have said 1. That goes right there. Okay, so you have about 10 questions in Delta Math to work on that. If you have any questions about these, send me an email or a remind and ask for a little extra clarity.